Hi there, welcome back. In a previous video, I went over the idea of sensitivity analysis and showed you how to read a sensitivity analysis report that Excel Solver produces. We went over the concepts of shadow prices and reduced costs and allowable increases and decreases of those ranges and so forth. If you have not seen that video and you're not familiar with any of these concepts, I suggest you look at that one before you watch this video here. So I'm going to leave a link to that video in the description of this video and also add a link to it for you to click at the top of the screen here. My goal with this video today is to simply give you more practice with these concepts. That is, we're going to go over another example of another story. We're going to generate the sensitivity report and answer some what-if questions using the report. Here's a story. There's an amusement park, Kinney Trail, and they're trying to divide their new 50-acre piece of land into 3 categories of activities: rides, food, and shops. Each acre used for rides generates $150 per hour in profit. Food generates $200 per hour, and the shop acres $300 per hour in profit. And there are some restrictions on how the space can be divided. Out of the 50, only 10 acres are suitable for shops. There are zoning regulations that require at least 1,000 trees in the park. A food acre can have 30 trees, a ride acre 20, and a shop acre no trees, and no more than 200 people can work in the park. This could be a fire marshal regulation. It takes 3 people to work an acre of rides, 6 to work an acre of food, and 5 an acre of shops. Let's model this problem, solve it, get the sensitivity report, and then answer some questions that are coming up below. Well, first, to model it, essentially we have 3 variables because we want to find out how to split the park land, right? So we could create a ride, food, shop, or RFS variables, representing respectively how many acres to dedicate to each of the 3 activities. And for maximizing profit, so our profit formula would be every acre of rides generates $150, every acre of food $200, every acre of shops $300. We have 50 acres in the park, so the acreage we use R plus F plus S at the most acreage we have. The S variable can be at the most 10 because they say only 10 of the 50 acres are suitable for shops. This is the tree requirement. I need at least, greater than or equal, 1,000 trees. Every ride acre 20 trees, every food acre 30 trees. Shop isn't here because there's no trees in shop acres. And finally, the occupation in terms of the employees, at the most 200 workers in the park. And these 3, 6, and 5 are how many workers each of the 3 activities require. So on the left here we have total number of workers at the most, total number of or maximum number of workers allowed. So if you take this, we do build the usual Excel model. I'm not going to go over that because that's not the point of this video. It's already set up here for us. Let's just solve this and generate the sensitivity report. Remember, you have to go after you click solve. When you see that window that comes back saying, hey, solver found a solution, before you're hitting OK here, you go and click sensitivity. And then you click OK to get the report. You see a new tab will pop up in the bottom here. So click OK there. See, now you see this new sensitivity report tab coming up. Let's go in there. And it has these 2 tables that we know how to read from the earlier video. So we're just going to use these numbers now to answer the questions in this story. And the questions are the following. What is the optimal allocation of the space? And what is the profit per hour of the park? Well, this is obviously if I didn't give you access to this sheet here, because the optimal allocation would be, no, this many acres for each activity, and the optimal profit is here. But if you could only see this table, or these two tables, you can still calculate that. Well, the final value column is what tells you what the optimal solution was, right? So for ride variable, it's 31.25 acres, food 12.5, and so on. And to calculate the profit, well, I know that I have this many acres making this much money each, this many acres making this much money, because objective coefficient column is the numbers that appear in front of your variables in the objective function. So if you wanted, you could actually do a sum product here between this and this, right? And that will calculate, should be, not by coincidence, exactly the same number that you have here. Okay. All right, so that answers part A. Suppose food only made a profit of 180 per hour. What would be the optimal allocation of the park, and what would the optimal profit per hour be? Well, food currently makes what? It makes 200, right? So they're asking you if this number were to go down to 180, or equivalently, if it were to go down by $20, would you change the allocation of the park? Well, you look at the allowable decrease, right? An allowable decrease for a objective coefficient of a variable basically says as long as that number goes down by no more than this, the current solution remains optimal. So I'm inquiring about a decrease of 20, which is way below the allowable decrease. Therefore, current solution remains optimal. I would still split the park area in this fashion, even if this number were 180. However, clearly, my profit per hour would not be the same 9,062.50. It would go down because now these 12.5 acres that used to make me $200 each now only make me $180 each. So the decrease in profit would be 20 times 12.5, which is $250. So if I were to, and I don't have to do that, change this number here from 200 to 180 and go and click solve again, I would see a new profit that is this number here minus 250. And again, the 250 is coming from the minus 20 times 12.5, because I lose $20 12.5 times. All right, great. Then part C. City Council would like to increase our tree requirement. Currently, they state you need 1,000 trees in a park of this size and type. But what if they said, you know what, I think you need 1,020 trees? How much will that cost us in dollar per hour? And what if they increased it to actually 1,200 instead of 1,020? Let's take a look. Well, first of all, what number is changing? Go back to your math and see the number that they're trying to change is this 1,000. So it's a number in the constraints that's changing. Therefore, you go to the constraint table, which is the second table. Locate that 1,000 is here. And the first thing you check is the proposed change within the allowable limits? Well, the first question was for an increase of 20, right? From 1,000 to 1,020. So an increase of 20 is clearly within the allowable. What does that mean? Does that mean the solution remains the same? No, it's not like the top table, and this is a common confusion. In the bottom table, a change being within the allowables simply means that you can use the shadow price to assess the impact of that change to the value of the optimal solution. In our case here, the value of the optimal solution is profit per hour of the park. So these shadow prices will always have the same unit as the objective function, because our objective function is in dollars per hour, all of these numbers here are also in dollars per hour. So back to the question, if this number went up by 20, what would happen to the value of your objective? Well, the impact to the objective of a change in a constraint right-hand side is the amount of change that is plus 20 times the shadow price. Right? So I can just point there. So if I do that, what this says is it's a negative number. Yes, what does that mean? It means that raising this number drives your objective down. And because I am maximizing, because it's a max profit problem, I don't like this, right? So always keep in mind what I mentioned in the other video, negative numbers in these tables are not necessarily bad or good all the time. It is all a matter of what is the sign of this number, what is the direction of the change you're proposing, is it an increase or decrease, and thirdly, what is your objective function? Are you trying to maximize or minimize, right? Because I am maximizing, negative changes to my objective are bad because they drive the objective down. But if I were minimizing, a change of this magnitude, a reduction, would be good. So for us, if the city council wants to increase this by $20, that would mean a loss in profit per hour of $87.5. And what if city council increased this to $1,200? Look at the allowable increase. The answer is, well, beyond the 166 trees, I can't really tell you exactly what the impact would be, because this shadow price would not be valid anymore. The most I can say is the first 166 and 2/3 trees that you add, each and every one of them would represent exactly a reduction of $4.37 per hour in my profit. Beyond those first 166, it would be another impact in terms of reducing my profit. All right, that's the most you can say there. And then the next question, the construction firm is willing to convert 5 acres of land to make them suitable for shops. Remember that we had this limitation originally, only 10, right, of our 50 acres were suitable for shops. This construction company approaches you and says, well, I could make this number 15 if you wanted. Do you want to, go for it? That's what they're asking. Well, again, it's a change in the constraints. Let's look at the constraint table and find the number that is changing. It's the 10. And they're proposing increasing the 10. Well, see, allowable increase this means infinity. So 5 is clearly less than infinity, so I can use the shadow price. Shadow price is 0. What does that mean? It means that raising this number by any amount doesn't do anything to the value of my objective. Neither hurts nor helps. Well, another, intuitive explanation for this is the following. Well, I have 10 acres to use. I'm currently not even using the 10 I have. Why would I want more of it? Okay, that's why this is a 0. So we turn to this company and say, no, thank you. I don't need more of my acres to become suitable for shops. There's no benefit there. And I think this is the last question is the following. They're considering putting in a water slide activity. So it's a new activity. It's not, if you call a water slide, could be considered a ride. But for our purposes here, this water slide is like a special kind of ride that isn't any of these currently there. Each acre of water slide can have 2 trees and requires 4 workers. What would be the profit necessary for this water slide activity to be a good idea, as in to help us, increase the profit? So what they're thinking about now is, let's say I had this brilliant idea. Oh man, I should put in a water slide. Yeah, all my competitors are doing it. Kids love it. It's going to bring more people into the park. But I'm not sure yet what the profit per hour would be. I have to do some market research or look at my competitors and things like that. But I know some things about the water slide. That is, how many trees it can have, how many workers it requires. So I could do a calculation here that says unless the profit per hour of water slides is at least so much, don't even bother pursuing that activity. Don't even waste your time with it, right? That's what we want to find out. Because then we can use that information to say, you know what, I don't think I can reach that value, so forget it. Or maybe I'll think, oh yes, this is very doable, so let's go for it. Right? That's what we want to find out. Well, because this means introducing a new variable, the proper way of going about it is this. First, go to your math. And if I had a fourth variable, the water slide variable, W variable, whatever you want to call it, right? It would become a new shaded cell here, right? If you want to make that, right? It's a new variable. And underneath it, there will be numbers. So does water slide use land? Of course it does. So I'm going to 1 in there. Does the water slide matter for the shop suitability constraint? Not really, because it's not a shop, so nothing there. Does it contribute to the tree requirement? Yes, right? Because a water slide can have 2 trees. So water slide would come in the tree constraint with a 2. And does it contribute to the worker constraint? Yes, because it needs workers, right? It needs 4. Great. 4 workers. So those will be the numbers in front of the water slide variable if I were to put the W variable in these formulas here. So to check whether or not a new variable that you're considering is a good idea, the calculation you perform is the one known as the reduced cost calculation. And it goes like this. You begin with what will be the profit or coefficient in the objective function for that variable. But for us, we don't know, right? We don't know what this is. But essentially, the calculation you do is this. The reduced cost would be, that number, question mark, minus what? You take every number that multiplies this variable in every constraint times the corresponding shadow price of that constraint that the sensitivity report gives you. Right? So let's do that. We can do the calculation here. Right? I want these values and do some product, right? Because it's number times number plus number times number, etc. So I can take these values here, right? Coefficient, that is number in front of variable, coefficient of water slide variable in constraints 1, 2, 3, 4 times the shadow prices of constraints 1, 2, 3, 4. Okay? If I go back here, did I put a comma after that already? Not yet. So it's going to be this set of 4 numbers, comma, this set of 4 numbers. Okay? And if I go back there, let's see if this cross-tab calculation works. Not really, right? So let me do this. I'm just going to make this simpler. Let's take these numbers here, copy them, and paste them here as the shadow prices. Okay, and now I'm going to calculate the product. Some product. These numbers times these numbers. Perfect. So the reduced cost of water slide, right? Would be whatever its profit is minus 260. Now, do I want this number, this result, to be positive or negative? Well, the reduced cost is the impact to the value of the objective were you to use 1 unit of this variable. Well, because my objective is a maximization objective, I would like that using water slides, I would like that to bring a positive, right, an increase to my objective value. So I would like this calculation to be greater than 0, right? Because that means the water slide has a positive impact to my profit maximization. Therefore, for a number minus 260 to be greater than 0, that number has to be greater than 260. Okay? As long as we find a way for the water slide activity to generate an hourly profit greater than $260, that would mean that putting it in as a new activity is beneficial. Now, of course, there are intangibles to be taken into account. And maybe if the profit is actually $260.01, even though that minus 260 equals a positive number that is 1 cent, maybe you'll be like, you know what, for 1 cent, I don't think it's worth it because it's so much hassle to, do all the other things involved. Or maybe you would think the other way. Even if this number is a little negative, let's say it's actually 250. So 250 minus 260 gives you a loss of $10 per hour. But because of intangibles, you're thinking, you know what? I can take a $10 per hour loss on this water slide activity because of all the other benefits that water slide brings. For example, it draws more people into my park, who in turn will consume more food. Or I can put on my ad on TV that I also have a water slide like my competitor, which makes me look better. So theoretically speaking, right, you would not pursue an activity if this number weren't positive. And any positive means go for it. In practice, of course, you bring in the intangibles. Look at what this value is. If you really need it to be positive, is it positive enough given everything else involved? Or maybe you can take a little loss as long as the loss is not too big. The important thing is this calculation will give you the exact number that you can look at to make this final call. And that's the whole point of this. All right? Great. I hope this has been helpful for you to practice a little more the use of the sensitivity report from Excel. And we'll do another example of this in another video. Nice having you all here. Thank you for watching as always, and I hope to see you back for more. Bye-bye.